This pencast is on linear inequalities in one variable. So our directions say solve the inequalities, graph the solution set, and write the solution set in interval notation. So notice with these set of directions, there's really three things. The first thing is to solve the inequality. The second thing is to graph the solution set. And then the third thing is to write the solution set in interval notation. So we need to make sure we do all three of these. In our first example, we have 3y plus 11 is greater than 5. Inequalities are not all that different from solving equations. The only difference is that if we have to multiply or divide both sides of the inequality by a negative, then we're going to flip that inequality sign. So in this one, if this were an equation, the first thing I would do is try to isolate the variable. So that's what I'm going to do. That means I need to get rid of this positive 11. And we get rid of positive 11 by subtracting 11 from both sides. Well, 11 minus 11 is 0, so that cancels. And I'm left with 3y is greater than, and then 5 minus 11 is going to give me negative 6. Now once again, I'm still trying to isolate this variable y. And right now y is being multiplied by 3, so I do the opposite. I divide by 3. Since I'm dividing by a positive 3, I do not need to flip the inequality sign. I would only flip it if I were dividing by a negative 3. So 3 divided by 3 is 1, and 1 times y is y. So those cancel, and I have y is greater than negative 6 divided by 3 is negative 2. So there's the first part. We've solved the inequality. Second part is that we're going to graph the inequality. So we draw our line, and somewhere in the middle of this line I'm going to put in 0. Now we know that negative 2 falls to the left. You don't have to be exact here. You just put a mark to the left of 0 and write negative 2. And now this says here y is greater than negative 2. So from negative 2, we want our line to go towards the larger numbers, so towards the right. And since y is strictly greater, we use a parenthesis. So we've graphed the solution set, and now we're going to write it in interval notation. And once you have the graph, it's very easy to write the interval notation. We know on the left side, it starts with a parenthesis at negative 2, and then it goes all the way to the right, so all the way to positive infinity. And remember, infinity symbols are always closed with a parenthesis. We never use a bracket. All right. So we've solved the inequality, we've graphed it, and we've written the solution set in interval notation. So we're done with that problem. In example B, we have 20 is less than or equal to 8 minus 1/3 x. It is completely up to you, but you may find it easier if you are working with a linear inequality with one variable in it to make sure that you have the variable on the left-hand side. Now, with an equation, I can just switch sides of the equation, and there's no problems with that. If I want to switch sides of an inequality, then I need to flip that inequality sign when I do so. Notice that right now, the larger part of the symbol is opening up towards the 8 minus 1/3 x. So when I flip this inequality, I want the larger portion of the symbol to still be pointing at the 8 minus 1/3 x. So I'm going to write this as 8 minus 1/3 x, flip my inequality, so we can see that the larger portion of that symbol is still pointing at the 8 minus 1/3 x, and then write my 20. Also notice that the smaller portion of the symbol was pointing at the 20, the smaller portion of the symbol is still pointing at the 20. Alright, so now I'm going to solve this. So I need to isolate the x, which means I need to get rid of this positive 8. I do that by subtracting 8 from both sides. 8 minus 8 is 0, so that cancels. So I'm left with this minus sign and then the 1/3 x, and we can now treat that as a negative. So that's negative 1/3 x is greater than or equal to 12. Now, I would like to get rid of this fraction 1/3, and I can always get rid of a fraction by multiplying by its reciprocal. And the reciprocal of negative 1/3 is negative 3. So I'm going to multiply both sides by negative 3. Now remember, when I multiply or divide by a negative, I have to flip that inequality sign. So negative 3 times negative 1/3 is 1, and 1x is just x. I need to flip that inequality. So the greater than or equal turns into a less than or equal. And then 12 times negative 3 is negative 36. So the reason I had to flip this inequality sign was because I multiplied by a negative on both sides. So we've solved our inequality. Now we're going to graph it. So say here 0. Somewhere to the left of 0 is negative 36. And this says x is less than or equal to negative 36. So first let's deal with the less than part. Less than means that the arrow should go to the left of negative 36. And since it's less than or equal, that means we need to use a bracket. So we've graphed the solution set. Now we're going to write down the interval notation. Well, this arrow goes all the way to the left, and all the way to the left is negative infinity. And then it goes all the way up to and includes negative 36. So we use that bracket. And there is our interval notation. Example C is what's called a compound linear inequality. And as you can see, the b is in an expression in the middle, and there are actually two inequality signs. One here and one here. So whatever we do to the middle, we need to do to both ends as well. So the first thing I'm going to do is change this minus 3 into a plus negative 3. Now I am trying to isolate the variable in the middle, which means I need to get rid of this negative 3. And I do that by adding the opposite, so I'm going to add positive 3 to both sides. Or to all three sides, I guess you could think of it that way. But whatever I do to one part of the inequality, I need to do to all three. Well, negative 3 plus 3 cancels, leaving me with negative 2b in the middle. And then I've got my inequality signs. 6 plus 3 is 9. And negative 6 plus 3 is negative 3. So now when I look to the middle, the b is being multiplied by negative 2. So I need to do the opposite. I need to use the opposite operation and divide by negative 2. So I will divide by negative 2 in all three parts. Since I am dividing by a negative, though, I need to flip all of these inequalities. So this greater than or equal turns into less than or equal, and this greater than turns into less than. Negative 2 divided by negative 2 is 1. 1 times b is just b. And then here I've got 9 divided by negative 2. Well, that fraction's not going to reduce, so the only thing I'm going to do is make sure I bring my negative up into my numerator. So that's negative 9 over 2. And then on the other side, negative 3 divided by negative 2, it can't be reduced, but a negative divided by a negative is positive. So those negative signs will cancel, and I'm left with just 3 halves. Now when we go to graph this, we have to be a little careful. Here we have 0 in the middle. Negative 9 halves is going to lie to the left of 0, where all the negatives are. So I'll put that over here somewhere. Halves. 3 halves is positive, so somewhere over here we're going to have 3 halves. And once again, we don't need to make sure that they're in some precise spot. We just want to set it up so that we can get a decent graph of it. Now, I'm going to look at each part independently, and I always read from the variable. So this says b is greater than or equal to negative 9 halves. So remember, I'm reading this way. So b, and then I encounter the large part of the symbol first when I read it backwards. So b is greater than or equal to negative 9 halves. So since b is greater than or equal to, the arrow is going to the right. And I'm only going to go up to the 0 for now. Also, since it's greater than or equal, that means I need to use a bracket here at negative 9 halves. Now when I do the second inequality, I'm reading from the b. So b is less than 3 halves. So since b is less than 3 halves, from 3 halves we go to the left. So once again, we're approaching 0. And you notice that those two lines now connect. And since b is strictly less than 3 halves, I'm going to use a parenthesis there. When we have a compound inequality like this, what we're doing is we're capturing an interval. So now we can see in our interval notation, we start with a bracket, and we have negative 9 halves, comma, 3 halves.